This is the continuation of performance in this problem. If a computer A runs the program in 10 seconds and the computer B runs the same program in 15 seconds, we have to determine how much faster the system A is than system B. We know the formula: the performance of A by performance of B equal to execution time of B by execution time of A. Whereas we have seen in the formula as X and Y, it is replaced as A and B for this problem. Okay, while substituting the values, thus the execution time of the computer B is 15 seconds. So 15 by execution time of computer A is 10 seconds. 15 by 10 equal to 1.5. Thus the system A is 1.5 times faster than system B. And next, this is also for performance calculation only, in which the metrics of execution time based on the clock cycles of the program is calculated using this formula. The execution time of the program is equal to clock cycle for a program into clock cycle time. This is nothing but the number of clock cycles which is required by the program for executing the instruction and the time required for execution of an individual clock cycle. If we multiply all these two factors, we will be calculating the execution time. And the execution time of the program can also be given as CPU clock cycle for a program divided by clock rate, whereas we have seen clock rate is inversely proportional to the clock cycles, so it is given as 1 by clock rate. And this is the next example we are seeing for processor performance. In this, a program runs for 10 seconds in a computer A for 2 GHz clock, and we are helping the designer to construct a system B which will run the same program in 6 seconds, comparatively 4 seconds faster than previous existing system. And this the designer has to determine the increase of clock rate which is possible and which will affect the rest of the CPU design of the computer B to require 1.2 times as many clock cycles as system A. Thus the clock rate what the designer must target has to be find out by using the previous formula which we have seen. Let us see. The formula is CPU time equal to CPU clock cycles by clock rate, whereas this runs in 10 seconds, right? So 10 seconds equal to CPU clock cycles divided by 2 GHz. It is represented as 2 into 10 to the power of 9 cycles per second. While inversing this, the CPU clock cycle of A is equal to 10 into 2 into 10 to the power of 9 clock cycles. So it can be written as 20 into 10 to the power of 9 cycles. In the same way, while substituting for the system B, the CPU time has to be of 6 seconds execution time. So 6 equal to 1.2 times it must be faster than A. So it is given as 1.2 into CPU clock cycle of A divided by clock rate of B. So in such a way, while inversing this, we know the value of clock rate, right? So we are substituting that in this formula, whereas clock rate equal to this 6 will be coming to the denominator and clock rate will be moved to the LHS side. So clock rate equal to 1.2 divided by 6 into 20 into 10 to the power of 9 cycles, whereas while performing the operations we will be having 4 into 10 to the power of 9 cycles per second, whereas it is known as 4 GHz. Thus the programmer has to build the system B which is having 4 GHz clock rate to attain the execution of that program to be completed within 6 seconds and comparatively 1.2 times faster than system A.